Great Barrier Reef, the world's most extensive coral reef, home to over 9,000 known species, with some of the most spectacular scenery on Earth, is currently threatened by climate change and human impact. There has been a global decline, with a loss of 14% of coral worldwide. Coral reefs experience something called regime shift. The reef may change from a healthy, coral-based ecosystem to a macroalgae-based one, having a severe impact on the services that the ecosystems provide. What are coral reefs? And what exactly is a coral? Corals are part of the Cnidaria phylum. In the tropics, corals are packed with symbiotic, single-celled algae called zooxanthellae. They use light for primary production on a healthy reef and thereby give the coral nutrients. Aside from that, the reef itself also provides different habitat services. Corals are known to provide the substrate for sessile organisms to attach. The diverse benthic flora and fauna, along with the calcium carbonate understructure, is a refuge from predation for invertebrates such as crabs, sea urchins, and brittle stars. Therefore, coral reefs are one of the most diverse ecosystems on the planet. On cues from the lunar cycle and the water temperature, entire colonies of coral reefs simultaneously release their gametes into the ocean in what is called the annual coral spawning event. This event is extremely important for the long-term survival and sustainability of reefs all over the world. So, what factors are responsible for making this shift from a coral-based system to a macroalgae-based system? Researchers have identified three main categories: drivers related to food production, such as fishing and the use of fertilizers, drivers related to climate change, such as global warming and ocean acidification, and drivers related to coastal development. Besides that, sudden short episodes of disturbances like storms, brief exposure to toxic pollutants, and siltation caused by dredging can also drive a regime to shift. What are the effects of this regime shift on the actual system? This regime shift occurs due to a positive feedback loop, which creates a reinforcing system. Macroalgae are able to colonize a part of the reef. They outcompete corals for light, meaning that the corals and the zooxanthellae receive less light. This negatively affects the zooxanthellae, and they start disappearing from the corals. This limits the corals in their functioning and ultimately their growth. The disappearance of corals frees more space, making more ground available for macroalgae colonization. Most regions exhibited an increase in the cover of algae, particularly in the Arabian Gulf, Eastern Tropical Pacific, Red Sea and surrounding areas, Caribbean, Australia, and Brazil.
So, what are the mechanisms behind these regime shifts? Ecosystems can have a gradual change, in which recovery follows the same trend of the initial change. Alternatively, they can have a hysteresis response, which after reaching a threshold is a catastrophic transition to an alternative stable state. Flipping the graph on its side, we can imagine a ball rolling out. In a stable system, if disturbed, the ball always returns to the same original position. In an unstable system, the ball can move to an alternative position when exposed to a disturbance, which then becomes a new stable state. As we can see, a higher threshold makes it more difficult for the ball to move back to its previous stable state. Thus, a higher threshold reduces recovery in the system. So what are the impacts of such a regime shift? A macroalgae regime inhibits settlement of coral larvae, as the larvae cannot settle on algae-covered substrate. This prevents the growth of new corals. Healthy coral reefs support commercial and subsistence fisheries, as well as jobs and businesses through tourism and recreation such as diving. Communities are severely impacted when coral reefs become less attractive. Besides the socio-economic impacts, the coral reef structure buffers shorelines against waves, storms, and floods, helping to prevent loss of life, property damage, and erosion. When reefs are damaged or destroyed, the absence of this natural barrier can increase the damage to coastal communities from normal wave action and violent storms.
So, what to do now? Well, one of the most obvious management strategies is decreasing the disturbance locally. Scientists want to preserve biodiversity by protecting parts of the coral reef from resource exploitation. Another strategy would be to increase the grass biomass by introducing more herbivores, such as sea urchin and fish. Algal biomass could also be removed manually from the reef. There are some limitations to the management strategies that need to be taken into account. Algal cover grows back fast, and zooxanthellae don't come back rapidly. In general, reef recovery is expensive and time-consuming. These management strategies are vital to prevent a regime shift, protect reef biodiversity, and facilitate sustainable use. So we have to aim to prevent the switch. We need to detect early warning signs to discover potential regime shifts before they occur. There are several ways to do that, and we get the most complete understanding of the reef when we combine monitoring, modeling, and mapping. This provides a clear understanding of the current conditions of the reef, how it developed in the past, and how it might develop in the future.
Overall, coral reefs are vital habitats for marine life and humans. At the same time, they are one of the most sensitive ecosystems to global change. We need to take coral reef conservation seriously in order to keep the coral reefs alive for future generations.